Hi and welcome to Maths class. Today we're looking at fractions, and this video really is meant to be a revision lesson for Year 7s who've been learning fractions for a while, but maybe they just want something that summarises everything they're supposed to know so far. So that's what we're going to do today. So the first thing we start in is we're looking at fractions. What are they? And what I've written there is when I divide things into parts, I can use fractions to describe the parts. And there's lots of different things I can divide. I can divide a whole, or I can divide a collection. For example, if I look at that rectangle, if I decide I want to divide it into thirds, I need to draw two lines like this, and that divides it into thirds. I'm going to take 1/3 and shade it. So I've shaded 1/3. I know they're thirds because 1, 2, 3. There are 3 of them. And I know that I've got 1/3 because I've shaded one piece. Now I can also divide this collection into thirds. I've got 4 columns and 3 rows. That means I've got 12 circles altogether. If I want 1/3 of them, that's 4. So I've got 4 out of 12, and that turns out to be the same as 1 out of 3. That's 1/3. So in a minute, I'm going to start talking about some key words for fractions, and some of the words are going to relate to the way these fractions work. We sometimes talk about the top and the bottom of a fraction, and really top and bottom is a bit vague. They've got special names, and I'm going to always use the proper names. The top of a fraction we call the numerator. The bottom of the fraction we call the denominator. So, if I look at those two words, numerator and denominator, what I'm going to look at in the word numerator, see how that start of the word almost looks like the word number. That's because the numerator tells us how many pieces we've got, the number of pieces. Then on the denominator, it's a bit harder in denominator to find out why it's called denominator, and the secret is in that little nom part, which is related to the word name. So the denominator names the pieces. For example, are they halves? Are they quarters? Are they tenths? So numerator tells me how many pieces. The denominator tells me what size they are. It names the pieces. So if I've got 3/10, then 3 is my numerator and 10 is my denominator. All right, I'm going to have a quick look at 3 other words that you've met before. One is proper fraction. A proper fraction is a fraction where the numerator is smaller than the denominator. For example, 2/7. See how the 2 is the smaller number and the 7 is the bigger number. That means that a proper fraction is a number between 0 and 1. It's a fraction of a whole. An improper fraction, on the other hand, has a numerator that's bigger than the denominator. For example, 5/3. The numerator is the bigger number and the denominator is the smaller number. That means that this is going to be a fraction that's bigger than 1 whole. 5/3, if I try to imagine 5/3 of something, that means I've got 1, 2, 3/3. That makes up the whole, like in my original diagram here. 1, 2, 3/3 makes up 1 whole. If I want 5/3, I'm going to need an extra 2/3. That's more than 1. Now, mixed numbers are the same as improper fractions, but rewritten. So 5/3 I could rewrite as 1 and 2/3. Now, when I'm writing mixed numbers, there's a kind of little invisible plus in there. I've got 1 whole plus 2/3. So this number here counts the wholes. Not donut holes, whole things, right? Then I've got a little bit more. So if I've got 1.5 cakes, I've got 1 whole cake and then a little bit more. The fraction tells me exactly how much of an extra cake I've got. 1/2 would mean I've divided it into 2 pieces. 1 piece has been eaten. I've got 1 piece left. So in this example, 1 2/3 would look like this. Let's make a cake. There's a whole cake. There's a second whole cake. I've got 1 2/3 of the cake. So I've got all of this cake still. And then 2/3. Thirds are tricky to draw with circles, but I'll do my best. I've just cut the cake into thirds. 1, 2, 3. I've got 2/3. There's 1/3. That's my second third. So that's 1 2/3. So remember, there's a kind of invisible plus there. I've got 1 whole plus I've got 2 pieces if the pieces are thirds. Another thing that's really important to remember about fractions is that the pieces need to be equal pieces. So in the example before, I took 1/3 of these 12 circles. That meant I needed to take 4 circles because that's exactly 1/3 of what I started with. Now, what if I didn't have equal pieces? If I tried to divide these 12 circles into 3 and I didn't get equal, it might look like this. I might give one person 3 circles. I might give somebody else 4 circles. And then I might give the last person 5 circles. These are not thirds because they're not all the same. Whereas if I go back to my original example, I started with 12. If I make 3 sets here that are all the same size, I've got one set of 4, another set of 4, and another set of 4. I've now got 3 sets the same size. In other words, I've got 3 parts of the 12 that are the same size. And remember, when I'm doing fractions, what I'm doing is I am dividing things into parts. But let's add up here, equal sized parts. All the parts need to be equal sized. Otherwise, it's not a fraction. Now we're going to talk about equivalent fractions, and soon we're going to start talking a little bit about simplifying and about cancelling. But before we do that, let's just look at what happens when we have equivalent fractions. To help me, I've made myself some toast. There's my toast. And what I've done is I've cut it into halves. They're more or less equal pieces, the best you can do with just a normal knife. And if you look at my halves, this half has just butter, and this half has some delicious chocolate spread. So I have 2 pieces, but I'm really only interested in the Nutella piece because that's the bit I want. So half my toast has Nutella on it, and it is a half because those 2 pieces are equal in size. But now I can hear my kids calling and they're going to want to share that Nutella piece with me. I've got 2 kids, so I'm going to share this piece into 3. I'm going to be fair and cut them all the same size. Okay, now I've cut the Nutella piece into 3. But to make sure that I can really understand what's happening with what I'm doing here, I'm going to cut this plain butter side into 3 as well, so that you can see what I've got. Now, I haven't changed the size of the Nutella piece. I still have half a piece of toast with Nutella, but another way that I can describe that half is that I've got 3 pieces and that each piece is 1/6 of a piece of toast. So the weird thing about dividing fractions is when I cut up the toast into more pieces, I have more pieces and the pieces are smaller. So let's just have a look for a start at my numerator. Because I started with 1/2. Right? I started with 1/2, which meant I had 1 piece and the size of them were halves. That 2 tells me that they're halves. Then I cut this 1 piece into 3 pieces. All right. So now I've got 3 pieces. I had to times it by 3 because I cut them into 3 pieces. I've got Nutella on my finger. Gone. Okay. But look also what happened to my denominator. I started with 2 pieces. 1, 2. Okay. It's happening again. I started with 2 pieces. But when I cut them up, I divided each of those halves into 3. I ended up with 6 pieces and I've got 3 of them. But the important thing here is this word equivalent. Equivalent is a lot like the word equal, and it starts with the beginning of equal. When you've got equivalent fractions, they're equal. So if I've got 1/2, that's actually equal to 3/6. See, when I cut up my toast, I didn't change how big that toast is. I've just cut it into 3 pieces. Now, simplifying is something that you've probably heard of, or maybe you've heard it called cancelling. And that's when I take my fraction that's been divided up more and I turn it into the number that is the simplest fraction. So when I cut up my toast, really, if I still look at the Nutella pieces, even though there are 6 pieces, I can see that half of those pieces have Nutella. So I've still got half a piece of toast with Nutella on it and half a piece of toast without Nutella on it. So instead of saying I've got 3/6, it might be easier for people to understand me if I say 1/2. So how do I know what is equal to 3/6? What I did up here was I timesed everything by 3, both in the numerator and in the denominator, to get my equivalent fraction. The opposite of timesing is dividing. So what I'm going to do is I'm going to divide the numerator and the denominator. Oops, that's the wrong way around. Let's do that again. I'm going to divide the numerator and the denominator by 3. 3 divided by 3 gives me 1. 6 divided by 3 gives me 2. I'm back where I started. So whenever I'm finding equivalent fractions, I can either multiply everything on the numerator and denominator by any number, or divide everything on the numerator and denominator by any number, but it's got to be the same number. So let's do an example. If I want to find an equivalent fraction for 1/5, but I actually need tenths, well, how do I make 10 out of 5? I'm going to multiply it by 2. So if I multiply the denominator by 2, then I also have to multiply the numerator by 2. So I end up with 2/10. What about going the other way and simplifying? I've got this number, 3/12. Oops, you can't see it. There it is, 3/12. and I've been told I need to simplify it to get the simplest possible fraction. How do I know what number I need to multiply or divide by? I'm not going to multiply because that won't make it into the smaller, simpler fraction. That will make it into something more complicated, and I want to simplify it. So what I'm looking for is a number that if I divide the numerator and the denominator by the same number, it will work. It will go evenly. In this case, the number is 3. 3 divided by 3 gives me 1. 12 divided by 3 gives me 4. So I've just worked out that 3 over 12 is the same as 1/4. Now, let's test this out. 3 over 12 is the same as 1/4. At the moment, I've got sixths for my toast. If I cut those pieces in half again, I'll have 12ths. So let's do it. Okay, that's the butter bit. Now let's do the Nutella bit. I've cut my toast into 12ths. Okay, let's just check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I've got 12, and they're all very close to being the same size. Some of them are a tiny bit bigger, but let's just pretend they're all exactly the same size. So what I'm testing out is 3/12 the same as 1/4? All right, so let's take 3/12. 1, 2, 3. If that's the same as 1/4, then I should be able to make 4 groups, and they will all have 3 in them. There's my second group of 3. There's my third group of 3. And there's my fourth group of 3. So you can see that if I've got 3 pieces, and the pieces are of size 12ths, then that's the same as having 1 piece when the pieces are size quarters. Oh, you caught me. I ate some of the Nutella pieces. Let's work out how much of the toast I've eaten. And we're going to use equivalent fractions. I can see there are 2 pieces missing, and the pieces, remember, are 12ths. So let's do that. I've got 2 12ths. I've eaten 2 12ths. I am going to eat the whole thing, I'll just tell you now. I've eaten 2 12ths, and I want to know how to simplify that. What's the fraction that I've eaten of the whole? So what number goes into both 2 and 12? The number is 2. I can go 2 divided by 2, and I can go 12 divided by 2, and I get a whole number each time. 2 divided by 2 is 1. 12 divided by 2 is 6. I've eaten 1/6 of my toast. Oops, get into... Why is it not coming into... Here we go. Now we can see it. I'm saying I've eaten 1/6 of my toast. So let's have a look. Remember, I originally divided my toast into sixths. That was 1/6, 2/6, 3/6, 4/6. There's 5/6, and it's the 6th sixth that's missing. So I am missing 1/6. See you later.